Now let's take a look at this together. It says an aeroplane flies from A to B. From A, we should take note of from A. That means our starting point is A. Centralize your hand in the middle of your book. This is our A. From A to B on a bearing of 070 degree. I've told you when you see 3 digits bearing like this, you start from the north. This is your north. 070 degree. No, it is 70. You cannot reach 90. Are you getting it? So 070 degree. And as soon as you get there, draw your another cardinal. Now these are 70. Now, an aeroplane flies from A to B on a bearing. This is B. 70 degree. And from B, from here to C on a bearing of 160 degree. Can you see? These are another 3 digits. Anytime you see from B now, you still come from to north because it's 3 digits. 160, 90, so 160 will stay around there because it is not up to 180. From B to C, so from B you make a 160 to C, so you bring your line out. Do you know why I'm drawing this B to C longer than A to B? Because when you look at here, it said A line, this means line AB, 5 kilometers. This one, line AB is just 5 kilometers. Why line BC is 12 kilometers. You know, you make another this thing here. This is your C. They said it's 12 kilometers. And this BC must be longer than the AB. That's why I make it longer. 12 kilometers. Now say find line AC. That means line from here to here. I believe you are getting it. So that means this bearing will come here. I'm doing it. There's no way you want to draw it here and bring it here. It's not possible. You come from this place and come and enter here. So you have to take note of that. So this is our line AC. This is our line AC. Again, let me say it again before I find the final answer. An aeroplane flies from A. Your starting point is A. So you make your 4 cardinal points. On a bearing, flies from A to B. Starting point is A. You want to fly to B. But you cannot just take it to B anyhow. You have to know on which bearing. On a bearing of 070 degree. This is 3 digits. And anytime you have 3 digits, you start from the north. 070 degree. So I start from the north. This is 70 degree. I draw it out. That is, when I draw it out, I make another 4 cardinal points. These are B. And from B, that means from there, these are B. To C, that means from B, you fly to C. On which bearing? On a bearing of 160 degrees. Anytime you see 3 digits, you start from the north. This is north. I make my 160. Don't let it reach 180. This is 160. So I bring it out. I'm going to C. I'm going to C. So I make another 4 cardinal points. And I told you, why do I draw this one longer than this? Because my line BC is 12 and my line AB is 5. This must be longer. So on 160 degree, I draw it out. If line AB is 5 kilometers and line BC is 12 kilometers, I make it and join it like this. Find line AC. So you know it has to come from here and enter. It cannot come from here. It is not possible from here and enter here. So that's why we are looking for this. Okay. How will I know? I told you in my former video that every bearing questions will only lead you to triangles. And either right angle triangle or acute angle triangle or obtuse angle triangle. If it is right angle triangle, I told you what to use. Go and check my former videos on sine and cosine rules. If it is right angle triangle, I've explained that one before. Now let's take a look at this kind of triangle. What is this triangle this one is giving us? How will I get it? How will I get the two? This thing, they come from here. So I will locate the angles here. This is 70 degree, comes like this. My alternate angle, like I told you earlier, you know, this thing is forming like this. What is here must be here. That is alternate angle. So I have 70 here. So 70 also must be here. Are you getting it now? Everything here is 160. So what will be remain here to make it here? That is 20. Because from here to here is 180. So 20. So everything that formed inside this triangle is 90 degrees. So where the two sides meet is here. That's where you will locate the angle. And the angle that is there will determine the kind of triangle that the thing resolves to. And this is 90 degrees. For you to have a 90 degree in a triangle, that shows that it's a right angled triangle. It's a right angled triangle. In fact, you can redraw it like this. You know, this thing is forming, anytime it's right angle triangle, is this triangle. So this is 90 degrees. And this is your 90. Can you see the way it faces? It faces here. That is your line AC that is facing. That's what we are looking for. So the two sides is 5 and 12. So 5, 12. And I'm looking for what is here. 5 kilometers and the 12 kilometers. Are you getting what I'm saying now? So if this is your B, capital letter B, this is our small letter B. This capital letter A is my small letter A. This capital letter C is my small letter C. So if I'm looking for this side now, I told you if you are solving right angle triangle, and you are looking the side of right angle triangle, you use Pythagoras theorem. And that is, Pythagoras theorem say h squared equals to o squared plus a squared. So the hypotenuse side is the side that faces the right angle, 90 degrees. So that's what we are looking for. And since the angle is not here, the angle is not here, you can take any of this side as your opposite. You can take any of this side as your adjacent. So far the angle is not here, the angle is not here. But if angle is here, so this place will be your opposite. If angle is here, this place will be your opposite. Since angle is not here, you can take any one of these sides as opposite and as the adjacent. So 5 squared plus 12 squared. That means a squared equals to 5 squared is 25 and 12 squared is 144. So that means a squared equals to 25 plus 144, that is 169. 169. So you square root both sides. So the hypotenuse is 13 kilometers. So decide here I'm looking for. That means line AC. Line AC equals to 13 kilometers. I hope you got what I'm saying. Let's solve one more for today. Now let's take a look at this. This is bearing and distance questions. An aeroplane from city A. From city A, our starting point is city A. City A. Don't forget, this is your north. This is your east. This is your west. And these are south. So, an aeroplane from city A on a bearing 135 degrees flies to another city B. That means on a bearing of 135, this is 90. So 135 should be around there because if you reach it, that is 180. You bring it up. You make your another focal point there. The bearing of 135, everything here is 135. Because it is 3 digits. So anytime you are drawing 3 digits, you start from north. That's why I start from north. And you know, this 90, 135 will be around there. Because everything is 180. So you bring it out from the point we join this. And you make your focal point here. So that, you know, they said an aeroplane flies from city A on a bearing of 135 degrees, flies to another city B. So this is our city B. a distance of 200 kilometers. He said from here to here is 200 kilometers. It then flies. That means when that aeroplane reaches city B, it flies from city B again. That's the meaning of it then flies to another city C. On which bearing? Although it's 250 kilometers, but don't just draw it. You have to know the bearing. Away on a bearing of 030 degree. And I told you anytime you see 3 digits, you start from north. So that means when you get to city B, you come to the north, 030 degree. 030 degree. So that means 30. You can't reach 90. This to 90, so you stop here. They said to city C on 250 kilometers. So you come here to bring your line out. It must be longer than this. This 200. Not 250 has to be longer than 200. So make your 4 cardinal points here. So this is 250 kilometers. So these are city C. City C. So, and this is 30. Don't forget. It's 30 degrees. Calculate the distance from city A to city C. This A, this C. I told you this one is longer, so you cannot bring it here. It's not possible. You come here to join it, and it's coming to join with this. You can't come here like this. It's not possible. So it's coming here to join with this. So this is a line. You have to find this city A to C. So if this is capital B, this one letter B, capital C, this one letter C, capital A, this one letter A. Now, I told you, how will you know this type of triangle that is here? Since this place is 30, and this is the quarter, this is the center, this is a place that join these two cities together. So this is where we are locating the angles. This is 30. How will I know what is here? To know what kind of triangle is this? I told you about the alternate angle. Okay? So how will I know what is there? If I know what is here. Okay, look at this. So that means if I know what is here, so I will know what is here. Alternate angle. You remember? What is here is what is here. So don't forget this is 135. 135 stop here. And if you complete it to here, it's 180. So 180 minus 135. 5. 7 minus 3, 4. So here is 45 degree. So that shows that this place also will be 45. So if this place is 45, so if I add the two together, 45 plus 30, that is 75. That is 75. So this triangle is not a right angle triangle. It's not a right angle triangle. It's an acute angle triangle. So that means you cannot use Pythagoras theorem here. You can only use sine rule or cosine rule. And what am I going to use? I told you, if you can check my last video on application of sine and cosine rule. I told you the condition to use cosine rule. This is cosine rule because I told that if you have a triangle in which you have two sides and one angle included, you will use cosine rule. So this one now, I have two sides and one angle included, and I'm looking for this. So I will use cosine rule. Okay? Now they said the distance from city A to city C correct to 3 significant figures. What is my cosine rule? I'm looking for B, small letter B, that is my figure 1. That's B squared equals to what? A squared plus C squared minus 2AC cos the letter is the angle. So that means B squared equals to, my A is 250 square plus, what's my C? 200 square minus 2 into bracket, plus 8 again, 250. Let's see, that is 200. Cos, what's the angle? 75 degree. So the B square was 250 square. So the 250 square is 62500. 62500. 200 square, that is 40,000. Minus, when you multiply 2 times 250 times 200, it gives us 100,000. And cos 75 gives us 0.2588. 0.2588. So that shows that the B square, because when you add the two together, give us 102,500. Okay, let's add it. Let's do the add. Sorry. We are having 62500, 40,000, 0052. So 1025500 minus. So when we multiply this by this, 100,000 times this, give me 25880. 25880. Is a 0. And the B square equals to, when I subtracted it, I'm having 76620. 76620. So I have to square root it. So this one cancel this. The square root of 76220, that is 276.8. 276.8 kilometers. But don't forget, they said to 3 significant figures. To 3 significant figures. 3 significant figures. That is 1, 2, 3. 2, 7. But this, before you write the last one, is the number up to 1, 8 is up to 1, you have it as 277 kilometers. So the 3 significant figure is 277 kilometers. That's from my figure 1. That is the distance, and then the distance from A to C here in 3 significant figure is 277 kilometers. Now look at the Roman figure 2. They ask us to find the bearing of the bearing of city A from city C. The bearing of city A from, take note of that, from city C. So that means you are coming here from city C. So you start from the north. I told you whenever you are looking for bearing, you start from the north of that place they ask you to find. City C. Anywhere you see, stop it. So that means anything you see from here down to here, you write it as a bearing of city A from city C. Now, how do we do that? Very simple. Sorry. Now, how will I get this? I know that from here to here is 180. I know this. Plus. Can I get here to here? Yes. Yes. How do I get here to here before I will not get this place? Here to here now. This is 30 now. You know our alternate angle. This is 30. So here is 30. So what I need now is from here to here. I need from here to here. Let me represent it as an angle. Now, for me to get here now, this place, I can use sine rule. I can use sine rule. So the sine rule is A over sine A equals to B over sine B equals to C over sine C. And how will I apply this? I told you, go and check my last video on application of sine and cosine rule. So please do so, please. How will I apply this? I'm looking for this. I have this. These are sides and these are angles. These are sides and these are angles. I can say I'm looking for this is CRV. I can say 200 over sine theta. I'm looking for, but I've gotten this. Don't use approximated value here. I got it as 276.8. 276.8 as here. All over. What is this? It faces this angle. Sine 75. Sine 75. So I'll just cross multiply. And it's by 200 sine 75 degree equals to 276.8 sine theta. That is 276.8. 276.8. That is sine theta equals to 200. What's sine 75? Sorry. So when I multiply this sine 75 times 200, it gives me 193. 193. Sine 75 times 200 give me 193. 193 over 276.8. So that means sine theta 193 divided by 276, it gives me 0.6973. 0.6973. That is over sine because you are looking for the angle. So the theta equals, you press your shift and sine. So I have sine 0.6973. So the angle here, it gives me 44.3. 44.3. 44.3. So I'll have it plus 44.3. So 180 plus 30, that is 210. So 210 plus 44.3 give me 251.3 degree. So that means the bearing of A from C, everything here to where you set the line, it is 254.3 degree. So for today, this is where I'm going to stop. So if you have any questions, just put it on the comment list, and I'll still upload more on this bearing. I'll upload more on this bearing until I feel like you guys are satisfied. It's a very simple topic. Thank you so much. Please do so to subscribe, to like, and to share. Teach others. Thank you so much.